The water level is at the top, and find the total force, key term, total force on the face of the dam. The formula, yes, F equals the integral, the rho times G. Rho is the density, G is the gravity constant, multiplied by the width, the depth, and the thickness. Okay. This time we have to create the origin, I mean the axis, the vertical axis. So since this is the symmetrical shape, similar way, we draw the y-axis right in the middle of the shape. And that is the position of the origin, 0. The water is on the top of the dam. What we have so far, we're gonna identify the position the of the water on the face of the dam. So identify this level. So that's the position Y. Okay, put the note on the side. So Y is the position on the dam. And with this, since the water is on the top of the dam, right? So the Y, or the interval of integration, will be from the lowest Y, which is 0, to the maximum Y, or the top of the dam, which is 20. The following part, the thickness, gonna be the delta Y, or dy. Since we consider one slab of water here with the Y position, we got the thickness. And for the depth, based on this position, you're gonna measure from this position to the top of the water, or the surface of the water. So this position to the top of the dam, so that is the depth. And this position is 20, and the current position is the Y. So it's gonna be 20 minus Y. Okay? So the depth, I put a note here, the depth equals 20 minus Y. The next part, width is done. So we're gonna, oh, wrong one, sorry. We got the depth. We're gonna work on the width. The width to consider, similar to the last problem, you just look at the widest part of the slab here. So gonna be from this end to this end of the slab that you consider. Okay. That means you're gonna go to the left and to the right equal amount. So go to the left x unit, go to the right x unit. Then the width that we're gonna have to put together gonna be 2x as well. But since everything will be with respect to y, we're gonna have to find the relationship of the x and y. How do we find that? As based on this position, you can see this order pair is gonna be x comma y, right? And what is the y? Is the y is on the line that's from the bottom of the dam to the top of the dam. That is in the relationship of the line, or the straight line. So we're gonna find out what is the y equation in terms of x, and then rearrange it. Uh, so the additional work for this problem is to find the equation of the line. Okay, to find equation of the line, we're gonna need the two order pairs, right? The first order pair, right, on the bottom of the dam, since the base is 10 meter wide, so to the left and to the right equal amount. So that means this is going to be at x equals 5 and the y is 0. And on the top of the dam, the widest part, like measure like 20 meters to the left to the right equal amount. So the x going to be 10 and the height is 15. Now we have two other pairs, 5 comma 0 and 10 comma 15. You find the equation of the line, you're going to need the slope. And the slope is y2 minus y1, right? y2 minus y1. divided by x2 minus x1. So we get 15 divided by 5 or 3. So we got the slope equals 3. To form the equation of the line, we use point slope form. So point slope form, which is y minus y1 equals m times x minus x1. The y1, just pick one order pair. I'm going to pick 5, 0. So y minus 0 equals m, which is 3 times x minus 5. So this will give me y equals 3x minus 15. But I'm going to need y here. Now we get the equation as y equals 3x minus 15. But we're going to need x in terms of y. So going to rearrange one more time. So y plus 15 equals 3x, or x equals 1 over 3 multiplied by y plus 15. It's more complicated than the previous problem, right? And with this one, back to the problem, the prep work here, we need the width in the terms of 2 times x from the x that related to the y in the form of 1 over 3 multiplied by y plus 15. And this can be the expression for the width that we're going to put in the problem. Okay, I'm going to add another slide and get the clean area work on the rest of the problem. So now from f equals integral from 0 to 25, which is the height of the dam, and the rho times g, and the width, I write the formula again, the width, the depth, the thickness. Rho and g can be pulled out of the integration. The width is twice of the equation of the line, which is 2 times 1/3 times y minus y plus 15, right? So we have, let me check, y plus 15. And then the depth is the top of the dam, which is the height 25 minus the position. The thickness is dy, and that's how we get the thing set up. 2 times 1 over 3, so that's another constant. I'm going to take it out as 2 over 3 times rho times g, integral from 0 to 25, y plus 15 multiplied by 25 minus y with respect to y. And what you're going to have to do, let me see, the height is 15, so I'm wrong. So here I have to fix it. Sorry about that. The height should be the y position. Okay, I fixed my thing here. I'm so sorry. So the depth, which is the position here, is 15. So it'll be 15 minus y. I'm wrong. I'm so sorry. That's why it didn't come out as the way it's supposed to. So this is going to be 15 minus y. Okay. 15 minus y, because in the y direction, the maximum y is 15. The position is the y. I try to get the problem in a clean way, but I just make a mess. So 15 minus y. All right, so we got depth, we got thickness, we got the width. Okay, I'm gonna clean up. And the height should be 15. Y from 0 to 15, not 20. See, I make another mistake. So 15, because the maximum y is 15, the minimum y is 0. Then make mistake all over. So 0 to 15, 0 to 15. This is 15 minus y, 15 minus y. And from 0 to 15, and simplify this to get 225 minus y squared before you find the antiderivative. and the answer should come out as 14700,000 Newton